Welcome surfers, it is Joele and this is Rustlers. In today's video, Atom 1.6, we are explore loops. Rust give you three different kinds of loop. The simple loop, the while and the for. Each one has a specific purpose and together they cover all the looping behavior you'll need in your software. And all of this without hidden side effects or implicit conversions. Let's start with the simple loop. The simple loop is the most primitive looping construct in Rust. It runs forever unless you explicitly stop it with the break keyword. Let's do an example. I can create a variable, a mutable variable called counter equals to 0, and let the result equal to loop counter plus 1. So in this line I increment by 1 unit my counter, and if counter is equal to 10 I break the loop and I return a value, the counter value. Okay, I need the semicolon, and now I can print. I can print the result. Okay, I forgot something. Yes, perfect. Let's give a try to this code. Okay, the result is 10. In this case, the loop run to the infinite and increase the counter, but when the counter reach the value I set, 10, with the break keyword I exit the loop and return this value. In Rust, a loop is an expression, so I can break it with a value, like the if construct and other construct in Rust. If you don't specify a value, the loop must return something, and in this case return the unit type. The unit type, we already talked about the unit type. The unit type in this case, unit type, is a simple empty tuple written like this. Okay, next, talk about the while. A while loop runs as long as its condition is true. So I can set another variable, in this case equal to 3. Okay, and while number is different from 0, I print the number and I decrease the value of the number, minus equal to 1. Okay, and here I can print the while loop is ended. Okay, now I can compile and run with cargo, and as you can see, this is a countdown from 3 to 1. And then I print this string, the while loop is ended. This construct looks like a classic while loop from all other languages, but Rust add to the while loop safety. The condition must be a boolean in any case. In this way you can't accidentally use an integer as condition, like you can do in C or in JavaScript or in other languages. Finally, we can talk about the for loop. This is the most idiomatic way to loop in Rust. It works with anything that implements the iterator trait, like arrays, like slices, or ranges, or your own iterator type. To test the for, I now declare an array of numbers equal to 10, 12, 13, 14, and is enough. For n in numbers, so for each integer inside the numbers iterable, I print this number. N. Perfect. Again, cargo run. And as you can see, I iterate through the entire array. 10, 12, 13, 14, the 4 integer inside this array. With the for construct, I can loop also ranges. Let's do an example of ranges looping. For I in 0 to 5, print I equals to something. Okay. And now run again this piece of code. Okay, what happened here? The for loop iterate through from 0 to 4, but why? Why this? In Rust, this range is exclusive, so this means that the end part of the range is excluded from the iteration. If I declare a range from 0 to 5, means 0 to 4. If I really want to include the 5, I must explicitly include it with an equal. Like this. Run again the loop, and as you can see, I in this case iterate from 0 to 5, 5 included. Another very important feature of loop in Rust are labels, because Rust support loop labels. A label make nested loops clearer and more controlled. Let's create an example. Now I declare a labeled loop. The label is outer and the loop is a for in the range 0, 3, so from 0 to 2. Inside this loop I create another loop for y in 0, 3. Okay, and now if x is equal to y, I skip this loop and I must move to the outer loop. So I write continue to outer. Okay. Else I can print, for example, x equal to something and y equal to something. X and y. Perfect. And now I need to close the inner loop and the outer loop. Perfect. Let's give a try to this code. I'm missing something. Yes, here. Try again. Okay, perfect. Here continue to outer skips directly to the next iteration of the outer loop. You can also use label to break a specific loop with using its label. This kind of use of the label keeps your control flow explicit, elegant, readable, and also safe. In summary, you can use loop when you need a manual exit or you need indefinite repetition. You can use while when you have a clear exit condition. And you can use for when you are iterating over something, but this something must implement the iterator trait. For today's video, it's all. See you in the next atom and don't forget to keep your thinking cap on.